Welcome back to another exciting chemistry lesson. In this lesson, we are going to learn how to use a periodic table to determine if an atom is going to lose, share, or gain electron, and specifically how many electrons that they need to gain, lose, or share to be least reactive, or in other words, to be stable. Now let's look at our periodic table. Looking at your periodic table, you should already have this periodic table label the number of valence electrons based on the group number and how many electrons are lost in specific group. So in this case, group 1A would lose 1 valence electron versus in group 7A would gain 1 valence electron. And if you notice, group 1A and group 7A are extremely reactive. In this case, 1A only need to lose 1 electron, where 7A just need to gain 1 more valence electron. Now let's go do some practice problem. First of all, we have this statement again. To be least reactive, atom gain, lose, or share the valence electron, so that they have the electron configuration of the nearest noble gas, which has a full outer energy level. So go back to your periodic table. This right here is your noble gas group, and which is the only group that is considered to be stable or inert. So if I'm looking at fluorine, I'm going to gain 1 more electron to have the electron configuration as neon. Notice how the fluorine, when it gains 1 electron, it doesn't become neon. It just have the look of neon. But in the end, the identity of fluorine is still the same because the number of proton does not change. So again, we are only changing the electron, which does not change the identity of the substance. Rather, it changes the chemical properties of that particular atoms. So now let's look at this. We have an aluminum atoms, right? It has how many valence and electron? So looking at your periodic table, so let's look at aluminum. In this case, aluminum is not going to gain 5 more electrons to have the same look as argon. So instead, it's going to lose its 3 valence electron and that outer shell as well. And what is it going to look like? It's going to look like neon. So let's go back and answer a question. So aluminum is in group 3A. It has 3 valence electron. It would need to do what? It would need to lose a total of 3 electrons. So the 3 electrons in their outermost ring will be completely lost to another atoms. Now, along with it, the outer ring that holds the 3 electrons will also be gone as well. So now once it lost its 3 valence electron, so it lost 3 electrons, so now it has the look of neon. So our atom want to have the electron configuration of a noble gas to be stable. So in this case, neon. Now let's do another problem. In this case, we have carbon atom. So carbon atom, let's look at carbon atoms on the periodic table. In this case, carbon is right here. It is in group 4A and it has 4 valence electron. Remember, the group A represents the number of valence electron. So right in the middle, carbon is going to share. It's going to share a total of 4 more electrons, so it has the same electron configuration as neon. So let's go back and plug it in. So in this case, carbon has 4 valence electrons. It would need to share. It's not going to gain or lose electron. Share a total of 4 electrons with other atoms. It could share with multiple atoms as well. So in this case, to have the same electron configuration, and it's turned out to be neon as well, as you can see over here. So when carbon share 4 more electrons, it will have the same electron configuration as neon. And there you go. Now let's go down to the last problem. Here we have oxygen. And the same thing, we go back to the periodic table, determine where the oxygen is on the periodic table, so that we know how many valence electrons it's going to be in order to determine it's going to share, gain, or lose electron. And what electron configuration it's going to have. In this case, oxygen is right here. Of course, it's going to gain 2 more electrons to have the same electron configuration as neon. It would be too much effort to go lose all 6 electrons and have the same electron configuration as helium. So in this case, oxygen is going to gain 2 more. So let's go back here. We have oxygen has 6 valence electrons. It would need to do what? It would need to gain, a total of 2 electrons to have the same electron configuration. In this case, is neon again. So that's just by coincidence, okay? So in this case, when oxygen gains 2 electrons, it will have the same electron configuration as the noble gas neon. And that is how you look at the periodic table to determine if an atom is going to gain, share or lose electron to have the same electron configuration of the nearby noble gas so that they can become stable as well. And as always, if you have any question, take a picture of your work, put in the forum, and we will help you from there. And we'll see you next time on another exciting chemistry lesson.